EdYoda, the end of your job search and the beginning of your dream career. EdYoda's live sessions are taught by industry experts, giving you hands-on experience and practical knowledge with real projects, not just degrees. EdYoda's industry-recognized certifications will help you stand out in the job market. And that's not all. With EdYoda's exclusive job board featuring 500+ companies, finding your dream job has never been easier. Say goodbye to endless job searching and hello to your dream career with EdYoda. Join EdYoda's student community today and start building your dream career.
Hi everyone, hope you all can see us. Welcome to the workshop. I hope you all are excited. We are also excited. And a quick check, I hope you all are able to hear us loud and clear. If yes, a quick hi in the chat box. Alright, great to see you all. And again, a quick reminder, if you haven't still clicked on that like button, now would be the right time to do it. A quick click on the like and click on the subscribe button and click on the bell icon also, so that you can keep getting notifications about workshops like this. So today, as you all know, our workshop is on exploratory data analysis in Python. Now, I know you all have heard about Python a lot, very famous. So let us know, how many of you know about Python in the chat box? And that is really something I know you all are excited about. And we'll be during the session learning everything about this. So stay tuned. We have Tanusha here with us. So before we have Tanusha speak, a quick question for you all. Where are you all watching this workshop from? I'll start first. I am doing this live stream from Bangalore. So Tanusha, where are you doing this live stream from?
Hey everyone, I'm in Kolkata right now.
All right, great. So we have people from different parts of the country connected via the net. Let us know in the chat box, where are you watching this workshop from? And to let you all know about EdYoda. So EdYoda is an e-learning platform where we educate on job relevant skills and then we connect you to job opportunities via our hiring partners. And this is one of our initiatives where we are trying to bring the knowledge to you so that you can apply for jobs in this field. And I won't waste any much of your time. I know you all are excited to learn from Tanusha. So I'll hand it over to her so that she can begin the session. So over to you, Tanusha.
Thank you, Rishabh. It was really a very nice introduction about Python and data analytics. So guys, just wanted to have a quick check. Are all of you students, graduates, or maybe working in a different field right now? Okay. So today we'll be starting off our first workshop series with exploratory data analysis. So first of all, when we talk about exploratory data analysis, what exactly do we mean and what exactly do we achieve, right? So all of you must have heard about these fancy job titles like data scientist, data analyst, product analyst, business analyst, and everything like that, right? So do you know what are the various skills that you need in order to get into there, to get to these jobs? So the very first thing is to know your data well. So unless you know your data very well, it will be very difficult for you to actually do further processes on it. So that's the purpose of today's video, which is on exploratory data analysis. And the agenda of this video would be to cover several steps that are normally done in an exploratory data analysis part. And we can say that this is the step one of any data analytics, of your data analytics journey. So whether you want to become a data scientist or a product analyst or even an analytics consultant, in either of these job roles, you'll have to first know your data well. And today we'll be doing that with Python, which is the most versatile language of all. So that would make our job very, very easy. So let me just dive right into the slides. So I'll just take a minute or so to open up my slide. Yeah. So So I hope you can see the slide over here. So my name is Tanusha Majumdar, and I've been with EdYoda since the past 1.5 years, and I've about 3+ years of work experience in data analytics. So I've worked with companies like ZS Associates, Accenture Strategy, and Swiggy, all in analytics-based roles. So I know where you guys are currently, and I was once a student as well. So even at that point of time, I used to ask my seniors that, okay, what to do in order to be a good data analyst, how to get started, right? So I know where you guys come from. So don't be worried. This is step 1, and we'll reach there. Okay. So first of all, this is an introduction about exploratory data analysis. So from here on, we'll refer to it as EDA. Okay. And the purpose of this presentation is to talk about EDA and why is it so important in data analytics and data science. So exploratory data analysis is the process of exploring and analyzing data to understand its characteristics and patterns, and it is essential for making informed decisions based on insights gained from the data. Right. So there might be many steps that are there in a data analysis project at any point of time. You might collect data from somewhere. You might perform different operations on that. And ultimately, you might actually run models on that. However, the first step would always be an exploratory data analysis, which consists of all these steps, which you can see here in the right chart, which includes data processing, data cleaning, modeling, raw data collection, visualization and reporting, and deployment. So all these data we get from the real world, and we have to manipulate that data and arrange that data in such a way so that your machine can make sense of it, right? And ultimately, this entire process makes immense contribution to the decision making of any organization, right? So, for example, you are in a company and your CFO or CMO tries to just tell you that what are the marketing sales in this particular month, right? And then you have all this data source which you're getting it from. But then you have to arrange your data in such a way, you need to filter your data in such a way that you can get to the required answer. Okay, so post this, we'll just get started on what are the various processes in exploratory data analysis. I hope you enjoy, and we'll be doing a lot of coding and hands-on as well. So make sure that you keep a notepad or something with you. Okay, so we'll be exploring how to collect, clean, and visualize data, and how to leverage statistics and data visualization techniques to prepare our data for machine learning and other advanced analytical methods. Okay, so just to revise what is EDA all about. So EDA is the process of analyzing and visualizing data to gain insights and understanding its characteristics, structure, patterns, and relationships. And what are the goals and objectives of EDA? So you can identify patterns and relationships which are not immediately apparent. For example, you might have a data where you have 2 columns, right? These 2 columns might be very related to each other, but that you can't look at or understand just by looking at the data, right? So you need to do several data visualization techniques, or you might need to do several descriptive statistics techniques in order to understand what are the patterns and relationships. Don't be afraid by these words right now. These are just buzzwords. We'll learn more about it in the later slides and all. Then to detect outliers and anomalies in the data that may require further investigation. So what are outliers? So outliers is any data that should not fall in the specific data. For example, you have in a particular class, you have all the CS computer science students, and they have a particular marks. And then suddenly you get a MEC guy who has some different marks altogether, and it is harming the overall distribution of the data. So you can call that as an outlier or an anomaly in the data, which requires further investigation. So there are different varieties. This is just one example. Then you have to check the quality of the data and ensure that it is suitable for analysis. So you might bring upon a survey data which consists of a lot of missing data. So you basically you want to perform a lot of analysis on it, but you ultimately see that a lot of data is missing, right? So checking the quality of the data is also important. Understanding if the data is ethical enough, that's also important. So these are the various processes and objectives that we have for EDA. Then generating hypotheses about the data and guiding further analysis, communicating the findings of the analysis to others in a clear and concise manner. Yes. So this is very important. In order to become a good analytics consultant or a data analyst in future, just coding or just building models is not enough. Your job would also be to be the bridge between the technical and the non-technical teams. So in my earlier years as a data analyst, I always what I had to do is I always had to do the analysis. I used to run a lot of SQL code. I used to run a lot of Python code and do a lot of statistical analysis. But the analysis results that we are getting, it's not important unless I'm able to communicate what it is all about, right? So communicating in a clear and concise manner to others is also very important. But to have that clarity, you need to do these steps. And lastly, to aid in decision making and problem solving based on data-driven insights. So we'll move on to the next slide. We'll be talking about the processes involved in EDA. Okay. So this is an image that I got from the internet, and this is a very really nice process flow that you can see here. So you can see identifying the goal and strategy. Once you identify what is the goal and strategy of a particular project, you get to data collection. There are various sources how you can actually get data. So you can either get it from various online resources, you can actually create surveys, you can get them from interviews, you can get them from a lot of data. A lot of sources, right? And after that, you need to do some attribute classification. What is attribute classification all about? Basically looking at your data, just looking at how many rows does it have, how many columns does it have, what are the important metrics that I have here, and what are the data types, right? So, so I think you guys must be familiar with these terms, data types or dimensions, right? So data types, just to give a brief recap of what data types is all about. So if you guys have done Python, so you will be familiar with integer, double, float, string and all these things. So they are about data types. Then you have an initial analysis, okay, which is called univariate, multivariate, quality, anomaly detection, okay. Then we have requirement verification. Then we have preparation, which is about data cleaning, data scaling, and data centering. Lastly, we have feature engineering, which is the final step before machine learning. Okay, so it's modeling or insights. So your end goal is always either building a model with a machine learning model with a specified accuracy, or getting insights for your company. So that's the end step, and feature engineering is the last step, and data collection is the first step. So let us dive right into the various processes that we have. Okay, so this is step one, data collection, which is a critical step in exploratory data analysis because it lays the foundation for all the subsequent analysis. Okay, so as I told, this is the first step in your EDA. And what are the various processes that you have in data collection? So in each of your companies, you will see that if you're working somewhere, you'll see that there are always some people who either get the data from their external stakeholders, or they try to get data from other companies if you are working in a service-based company. So you'll see that data collection is the most important step, and all the analysis, everything you do, be it running a SQL query or trying to build a model, all happens on this particular data. So this is the step that this particular guy in your company, they'll collect the data. Then this data would be fed to the tables by the data engineering team. And after that, you will be doing all these analysis on that. Okay. So here are a few reasons why data collection is crucial in EDA. So it ensures the accuracy and reliability of the analysis. It helps in identifying data gaps and outliers, provides a comprehensive view of data, and enables hypothesis testing. Okay. So data collection is crucial because it definitely helps you with the accuracy and reliability of your analysis and identifying data gaps and outliers. Okay, what is hypothesis testing? This is a very interesting word. So basically, hypothesis testing is a statistical analysis where you get various insights based on your data. So just by looking at your data and doing some statistical analysis, you try to understand what is the result. Okay, so once we have data collection, so let us see what are some challenges of data collection. So these are three main challenges that we have for data collection. One is sample bias, one is measurement bias, and one is data management or data loss. Okay, so what is sample bias? Sample bias occurs when the sample used in the study is not representative of the population being studied. And this can lead to inaccurate and unreliable data. Okay, so let me give you one example of how sample bias might have been used in your day-to-day life. Okay, so suppose people in your college, they are taking some survey. Okay, and they're asking the CS-based students that, oh, how was the placement season this year? And all the CS-based students say, oh, we had a very nice placement season, 100% placed and everything. And then these people from the other branches, be it an ECE person or a triple E person or a MEC person, they are saying, oh, how is that even coming to place? In our branch, the placement is not even 50%. So that is an example of sample bias. I'm giving this example because been there. I have been an ECE student, so been there. So that is one example of how sample bias is used. So it's used when the sample used in the study is not representative of the population being studied. In this case, the population is your entire college. So just picking up CSE students for a feedback is called sample bias. So what you essentially need to do is, suppose you have 100 students in your college campus and 20 each from CSE, ECE, triple E, MEC and civil, for example. Then if you want to take a sample of 10, you need to take 2 each from all of these in order to get the actual sample score. Okay. So that is one challenge of data collection. And if your data has a lot of sample bias, the entire point of doing any kind of data analysis is perfectly futile. I'll tell you that. Okay. Then next we have measurement bias. So measurement bias occurs when the measure used to collect data is not accurate or reliable. This can lead to inaccurate and unreliable data. So one more example of measurement bias you can say is, for example, there is a company who takes in freshers having an 8 GPA, right? So in your batch, all you guys have studied a lot and you studied very much and you still got 7.5. Okay. Because your teacher who had actually graded the sheet was kind of a strict person. And the next batch, they have all got 9 point something, 10 point something, then not 10 point something, but they have got something. Because the teacher who was grading these sheets was completely a different person. And that's the reason why they got those high CGPAs. However, the company does not know that, right? And the company will take people from the next batch. Again, this is a true story, and this is what has happened with me as well. So this is again another example of measurement bias, where the measure used to collect data is not accurate or reliable. So whenever, whenever you are trying to collect data, you need to ensure that there is uniformity or homogeneity in it. So if you collect 2 kinds of data from 2 different sources, there is no way that you can understand which is right and which is wrong, right? So that is one example of measurement bias. Then lastly, we have data management or data loss. Collecting and managing large amounts of data can be challenging, particularly when using multiple sources of data formats. It is essential to have a clear plan for managing data throughout the research process. Missing values or loss of data is another big challenge. Again, another example of data loss would be, suppose you have a patient record. Okay. So there is a hospital record where there is a record of all the different patients. And suppose suddenly there is one day the person who makes all these records is absent. And there is no other person who is taking charge of writing these all data, right? And suddenly then one day you want to analyze how many people had come to the hospital with an inquiry of, say a tumor or something, just giving an extreme example. But then you will see that the number might be less than the actual number of patients who had been enrolled in the hospital in that particular month. Why is that? Because there has been missing values or loss of data. So this is also something you need to understand and you need to analyze well. Suppose if you're doing a monthly data analysis and you see that there have been no entries for 2 or more days in that particular month, you might wonder that maybe this might not be the exact number. Might be there is some missing value or loss of data. Okay, so these are few challenges that you have for data collection, which is sample bias, measurement bias, and data management or data loss. Either case, we have methods in order to deal with all of these. You can either remove these rows in order, if you see that there is less number of rows that are being affected, then you can remove these rows in order to bring that amount of homogeneity into your data. Or you can also check these data again. Okay. Now, post data collection, our next step would be data cleaning. So I'll say this is the most critical step in your data analysis process, because it's a very critical step in data analysis process and involves identification and addressing errors, inconsistencies, and missing data in the data set. So whatever flaws and all that you could see in the data collection step, they can easily be handled in the data cleaning step. And here are some of the most common data cleaning practices. That is handling missing data, handling outliers, checking for inconsistencies and errors, and standardizing and transforming data. Okay, so here is a quick trivia. So you might think that data scientists might spend most of their time actually building models or writing code for machine learning, right? But that is not so. Data scientists spend 60% of their time on cleaning data alone, which is not even 100% of EDA, right? So this is the importance of EDA, and this is so much important even for data scientists that if they don't get the right kind of data, the model won't simply run, right? So these are the various steps and why data cleaning is so important. In just a while, I would be opening up a screen where I would be showing you how exactly data cleaning is being used in order to handle missing data, outliers, inconsistencies and errors, and standardizing and transforming data. Before that, I wanted to give you some examples of data cleaning methods. So we understand that you might have few questions while you are watching this video. So keep your questions, just keep writing them on the chat. We towards the end, we'll have a Q&A session where I'll be trying to answer most of your questions. Okay, so these are some examples of data cleaning methods. So for example, in a survey data set, missing values for a particular question could be imputed based on the respondent's other answers or deleted if the missing values exceed a certain threshold. So this is about how you handle a missing value. Okay, so whenever I take my live classes for students, I always give them a formula. Okay, that how can you identify how to understand and how to tackle missing values. So when you actually start with your data analytics journey, right, you'll see that missing value handling is probably the most important step, even in data cleaning. So that's the most important step. So there are various methods how you can actually understand how to handle those missing values. So for example, if you have say 3 to 5% of your data which is missing, in that case, what you need to do is you need to remove those particular rows, because even if you remove them, there won't be much data loss. So that's what you need to try to find out. You need to find out a balance between data loss and not getting way into unruly data. Then if you have some missing values, but the variables that you have, they are like height or weight or other numerical variables, then you can just do a mean median mode of everything. Or if you see that, suppose there is a column in your data where you have more than 90% of values which are missing. In that case, you can simply drop the column. So this is basically a formula that I use a lot, but I won't be doing that for now. I'll just give you some examples and we'll take help of a small data set in order to show you this. Then in a data set of exam scores, an outlier that is far from the mean and other observations could be investigated for data entry errors or other anomalies and either corrected or removed. So outlier is something that I was talking about earlier. So whatever data that is far away from the average data of the other people can be called an outlier, and you can investigate that or remove that basis on certain conditions. Then in a data set of medical records, inconsistencies such as a patient's age being recorded as 150 years old could be corrected to reflect a more accurate value. So when you're doing your data analysis, you need to actually check, that what are the various variables which are there. Okay, so inconsistencies such as this might bring about a lot of difference in your data, and this can be corrected as well. And lastly, you have this example where in a data set of temperatures recorded in different units, example Celsius, Fahrenheit, the data can be standardized to a consistent unit. So consistency is also very important. For example, you have one column which is totally recording temperatures in Celsius and another column which is recording temperatures in Fahrenheit. And suppose you need to create a new column where you are subtracting both of these temperatures, just a hypothetical scenario, then you won't be getting the correct answer if you actually keep it that way. So standardizing is also a very important method. Okay, so before going to data visualization, what I'll be doing is I'll just be exiting the slide for now, and I'll be opening up my screen. Okay. I hope this is visible. So for people who have not used this environment before, this is a Jupyter notebook, which you should definitely download on your laptop or computer. You should download it from Anaconda, and then you should have this running in your laptop. So I like it for various reasons. So you can actually, whatever line of code you're writing, you can actually look at that with respect to each line. So this is a Jupyter notebook, and I have one data frame which I would like to show you for this particular analysis. Okay. Okay, so this is a data frame. This is a sample data frame. You can, just by looking at the data, you can see that there are 20 rows. There are 3 columns having data about name, age, and salary. Okay, now you can see that in some of the cells, you can see something called NAN. Okay, now what exactly is NAN? NAN means not a number. These are the missing values which are there. So once you do a pd.read CSV, okay, before all that, let me explain you what is all this. So I don't know if you have heard these names, but Pandas and NumPy are 2 most important libraries that you use for your data analysis and machine learning purposes. Okay. So while NumPy is mostly a numerical data structure, data library, Pandas, on the other hand, supports both numerical as well as categorical variables. So what is numerical? Everything, these 50,000, 25, whatever numerical, wherever you can see numbers, they are called numerical data types. And wherever you can see any letters or any structure there, they are called categorical data types. Okay. So first of all, we have imported Pandas over here. Then we have imported NumPy. And then we have created a simple data frame. So for now, you don't need to think about what is a data frame. Data frame is basically the data structure on which you do all these analysis on. So whenever you actually download a file and upload it from outside, what you need to do is you need to do a pd.read CSV, and then the entire data would be uploaded into your file. So this is the data. Okay. And now what I need to do is, I can see a lot of missing data here. So missing data means wherever you can see NAN, that's the missing value. Okay. So how do we handle it? How do we do different analysis on it? So let me write down the code for all of this. So the first thing is handling missing values. Okay. So you can see that there are a couple of missing values over here. There are about 2-3 missing values. No, there is 1 missing value in age and 2 missing values in salary. Okay, so what to do? How to handle this? Okay, so since both of these columns over here, they are your numerical columns. So what you need to do, first you need to check what is the percentage of data that is having NAN. So as you can see in the age category over here, out of 20, there is only 1 row which is missing. Okay, there is just 1 entry which is missing, which means 19 by 20, that is 95% of your data is still there. So what you need to do, you don't need to eliminate anything. You just need to replace. Your specific, wherever you can find NAN, you just need to replace it with something else. Now, when you replace it with something else, you consider the 3 most prominent things, that is mean, median, and mode. In this particular case, what we can see is mostly the ages of people are uniformly distributed. So we can do a mean over here. So we can fill in these the age column with a mean value. And that is what we are going to do. Even in salary, you can see that only 2 values out of 20, they are missing. So we can again do a mean here, because we can see that the range is between 50,000 and 97,000. So it's not a very big difference that you can see. So there are no outliers and stuff like that here. So you can do a mean here. Sorry. So how do we do that? So the name of our data frame is DF. Okay. How do I fill missing values with a particular value? So I use the function fill NA. Okay. Now what do I fill this with? I'll fill these with the mean of the remaining data. So I just need to do df dot mean. Okay, and that would be all. So now you can ask me what is in place is equal to true. So in place is equal to true means whatever changes that you are doing in your data frame, that stays. So you don't need to assign it again. So you guys, while you might have done some coding in C, C++, or even Python, you must have done something like A is equal to A plus 1, right? So you could just do so this a parallel of that would be A is equal to A plus 1 and in place is equal to true. You just add 1 and you write in place is equal to true. So you don't need to do that assigning again. An alternative to this would be df is equal to df.fill NA, df.mean. Okay. So just to explain again what we are doing with this code, we are filling the NaN values, which is not a number, using this function called df.fill NA, and we are filling this with the mean. Okay. Now, if you look at the data clearly, you can see that here in this particular case, this row number 5, you can see that the age is 30.42. Okay, so this is the value that we have computed from the mean of the remaining 19 people's age. And then again, you can see here salary 73,166 and even for this row. Okay, so we have handled missing values. Now what's next? What was the next step? The next step was handling outliers. Okay, so first of all, before telling you what is outliers, I would just like to give you a brief understanding, a mathematical understanding of what outliers is all about. Okay, so I'll just take a minute. What you can do is, for example, you have this data, right? Suppose this is a graph you have, and you have several points which are there. And then suddenly you have, you have one point. Sorry, I'm not getting the color. Suppose you have one point which is, oh God, forget it. Suppose you have one point which is totally in the, somewhere else. So let me just open a new sheet. So, oh God, just give me a minute. Okay, so suppose you have this, right? And you have several points which are here, which are clustered around here. So it can be, suppose, an age category, and suppose the age is 20, 21 and all this. So everything here is in this category, and then suddenly you have an age which is here, which is say 70. Okay, so that you can call as an outlier. Okay, so it's not within the regular scale. So how do we define this mathematically? How do we define outliers mathematically? So you have something called as Q3 and something called as Q1. So Q1 is the first quartile or the 25th percentile of data. And Q3 is the third quartile or the 75th percentile of data. So then you find out what is the difference between the interquartile range, and what you need to find out that if your data lies above Q3 plus 1.5 times of the interquartile range, then it's an outlier. Again, if you see that your data lies below Q1 minus 1.5 times of the interquartile range, you can say that that is an outlier. Okay, so there are numerous methods, how you can actually deal with outliers. So just to give you again a brief understanding what I was talking about so far, in case you did not understand. So outlier handling is also another major step that you need to do in data cleaning. Okay, so you might have a lot of data, but you might have a lot of data that is not relevant for you. And outlier removal is one of them. So how do you remove it? And how do you define an outlier? So you have Q1 and Q3, which is the 25th and the 75th percentile respectively. So any data which is greater than Q3 plus 1.5 times of the interquartile range. What is interquartile range? It is Q3 subtracted by Q1. Okay. And which is greater than this value is an outlier. And then again, another value, which, for example, you had some value which was here, for example, that this would also be considered as an outlier. Okay. So not only higher values towards the end, even values which are lower than the general threshold, even they can be called as a outlier. Okay, so there are 2-3 ways how you can actually handle these outliers. So one of the ways that I technically like a lot is using a box plot. So box plot is a data visualization technique where you can actually look at your data and you can see all those data points which are above Q3, the third quartile, and which are below Q1. So you can actually look at that in a data visualistic style. However, here we'll be using a different kind of concept, which is called a Z-score. So I'll explain you again later on what is a Z-score. For now, let me show you how it looks like. Okay, so I'll be creating a function which is called def of remove outliers. Def column. And then we have Z-score. Threshold is equal to 3. Okay, I'll explain you later why we are setting this as 3 and all. Okay, so stay tuned for that till the end of the class. Okay, so now we have Z-scores. This is a mathematical formula actually, how you actually get into Z-scores. df of column minus df of column dot me divided by df of column dot standard deviation. Okay, so this is the formula that you have for Z-scores. And then what you do, you actually run, you save this on a variable df outliers removed is equal to df dot. Actually, there are inbuilt functions also for that, but I wanted to show you the math behind that. That's why I'm taking this method. Score less than equal to Z-score of threshold. Okay, and then we are returning this on df outliers. Sorry. When you have df is equal to remove outliers. Yes. Salary. Just a second. Score. Yeah. So you can see that all the columns have been returned, which means that there has been no difference. Okay, which means that there has been no outliers over here. So everything you can see is in the normal range, which is between Q1 and Q3. Okay, in that case, you can see that all the 20 rows you can find over here and everything is between Q1 and Q3. So yeah, but this is the function of remove outliers. Just give me a minute. Okay. Then the next step was check for inconsistencies or errors. Check for inconsistencies or errors. So how do you check this? So you can save a condition on your own in this particular case. So you can either see that if the age is greater than 18 and less than 60, then we can say that the person is maybe should be having a salary or something, should be a salaried employee. Okay, so let us consider that and let us set the conditions. So df of age is greater than equal to 18 and df of age is less than equal to 60. Okay. So now I run this code again. So you can see that again 20 rows have been found out. So for example, just to tweak things a little bit, let me change this all. Let me change this 40 into say 67. A person has retired also and is still getting salary. Let's take that example. And suppose your salary in place of 75,000 is 7,50,000. Suppose somebody has done an extra zero. These are all fictional cases. Don't expect to get 7,50,000 in India. So 7,50,000. Okay. So this is your data. Let us run these things again. So now you can see that since you did a mean over here, you can see even the person for whom you have filled the data, you filled the missing data, even that person has a huge data, right? So you can see now, if you run this, you'll see that the person for whom you had filled the missing data, even he or she has a 1,01,000, which is greater than most of the people in the group, just because I had set a 7,50,000 data. Okay, so that is an anomaly, right? That is an anomaly. And again, you can see that for this particular person, Emma, whom I had done this, you can see that the age has by default added up to 31.84. So the place from where I had collected this data was a very authentic source. That's why the mean would do. But for example, you have this data where everything is differing by such a great extent. In that case, mean might not be a very good way to handle your missing values. In that case, we can use df.median. I'll give an interesting example as well when we do this. So now you can see that Jessica's salary has again been changed to 73,166, which makes more sense than 7,50,000, right? Okay, so now if we do the Z-score again, you can see that things have changed slightly. Okay, then if you want to check for inconsistencies, just a second, I'll run this from the top. So now you see that there has been one missing row. So you just need to check it like this. You just need to reset the index. True. Now, if you do the reset index, you can see that there are 18 rows, right? There have been 18 rows and people have been removed either due to the outliers. So if you carefully look at this data, you can see that the person for whom I had filled in 7,50,000 is not here anymore, right? That person is not here anymore. You can only see everything in thousands, not in lakhs, because that person was an outlier. It's way greater than Q3 plus 1.5 multiplied by interquartile range. Okay, so that's the reason why that person has been eliminated here. That's the first elimination. And the second elimination is the person with age 67. Right, so if you look at this, you have 18 rows. One row was eliminated in the outlier case, and one row has been eliminated when I set a particular condition of inconsistencies and errors. Okay, now what I can do is standardize and transform data. So let me show you how we do that. And after that, we have done enough coding, and then we'll move back to our slide. Okay. DF of standardized.
Tanusha,
Yeah.
1 second. Can you check your screen sharing once? Can you just switch it off and switch it on once?
Sure.
Yeah.
Can you see the coding screen? Rishabh, can you just confirm?
Yes, we can see.
Okay. Cool. So I hope you saw the screen before that, whatever I was discussing. So I'll just give you a brief recap if you didn't. So at first we had a very standardized data where every person's age was between 18 and 60, and the salary, everything was in thousand. So that's why we were not getting any data for filtering on age or getting something on the salary. So what we are doing is I had tweaked these parameters slightly. I changed a person's age to 67 and made one person's salary from 75,000 to 7,50,000. And then we were doing this analysis, right? And you could see that your data was being handled well. So there was from 20, it moved down to 80. So that is what you need to do. The last step of this is standardizing and transforming of data. So DF of salary. This is again a lot of math that you need to do. So salary. So I have changed the salaries. I've changed the salary figures and age squared to something. So right now you won't find this you won't find this very useful, that why have I done this step. But once you do machine learning and all those steps, right, you will understand that why this step was done. Okay, so we won't delve deeper into this right now. The purpose of doing this was you could actually standardize and transform your data. So it's not the fact that once you have a data, it has to be that way. You can actually modify your data in different ways according to your purpose. Okay, so I'll just move back to the screen again. So just a second. So I hope you can see my slide again. So we had last done data cleaning, right? So now we are talking about effective data visualization. So just by looking at the chart on the right, you must be familiar with the terms that are used. You might have heard of tools such as Power BI, Tableau, ClickView, then even MS Excel, Google Sheets. And what comes to your mind when you are talking about these? All those beautiful charts and everything comes to your mind. You can do such a huge lot of things that you can do with these various tools. However, good news is you can do this even with Python, right? So we'll be doing some of the codes as well in Python. So on Python, you have these libraries like Seaborn and Matplotlib, in which you can make equally, if not more, beautiful distributions here. So just to give you a brief overview of what data visualization is all about and why we need to do data visualization. So data visualization is the art of presenting data in visual form to facilitate understanding and analysis. So first thing is choose the right visualization. So this is also something I tell my students a lot, that you need to understand what visualization exactly you are choosing, right? So suppose you want to just plot one variable and try to understand what is the average of all them. You need to choose a bar graph, right? You cannot do the same thing using a scatter plot. Okay, so each graph has each purpose, and you need to understand which one is used when. Okay, so then it emphasizes on clarity and simplicity. Okay, so if you see huge Excel data, you have 20,000 rows of Excel. Okay, just by looking at that, you won't even feel like working on that. One day my then manager had given me, see, this is 50,000 rows of data. You need to compress this and you to get data out of this and all. I was like, what is this? How can I not make some visualization out of this? Okay, so that is the art. That ever more than having 20,000 rows of actually data, it's even that does not bring a lot of clarity into your mind or the person's mind whom you're going to present something. Clarity is always brought about by anything pictorial, right? So even when you are kids, you must be liking drawing and everything a lot, right? You must not be liking math and everything. There might be exceptions, but this is an example. Okay. That's the reason why clarity and simplicity is important, and that is brought about by these graphs that you can see here. This is a small pictorial representation of the graph, but it also shows you how important data visualization can be and how much information it can get you. And it can highlight patterns and relationships. This is very important because you might not understand that two data points are very closely related to each other. For example, say you are in first semester. Okay, you're very motivated, and then you study for 8 hours every day. You study for 8 hours every day, and you see that you got a 9.5 GPA. Okay. Then starting from second year and third year, you see that, oh, I want to do a lot of different things. I don't want to study this much. Okay, let me do sports, let me do music, dance and everything. Then you bring down that number, right? You bring down that number from 8 hours to maybe 2 hours, and till then to the night before the examinations. And then you see the dip in your marks, right? You see that your 9 GPA changed into 7 GPA in no time. And this happened to me as well. All the examples I'm citing here, they happened with me. So I scored very well in first semester and scored very bad in the towards the end. So that's what happened. And then you can identify what are the patterns and the relationships. So now, if my life was a data in that particular sense, you can see that study hours would be somewhat correlational to your GPA. Almost, although it's very qualitative and it's a debational topic. It's a topic for debate. So. But you will still find a positive correlation between study hours is to the GPA you get. You can get many more examples such as this, which we'll talk about. We'll also do some more coding in Seaborn. Sorry. But now, just look at the slide that we're talking about. Then contextualize the visualization. Okay, so from the examples here, you can see that we have a couple of graphs here. First is just a basic representation of what the data is all about. For example, you can say 40% of this, 75% of this. So from the looks of it, you know that these are two separate categories. These are two separate categories. For example, this can mean something like the number of women in a particular company is 40%. And then you can say that people who work from office is to people who work from home, say 75% to 25%. That can be what this data is talking about. So you just by looking at it, you need to understand what this data might convey. Okay, then you can see the graph below it. You can see this looks like a line graph. So when was the last time that you found a line graph anywhere? Honestly, in my experience, I found a line graph last when I was anxiously tracking all those COVID-19 numbers. So these points over here, they can actually be your various dates or various week on week number or day on day numbers. And you can see that COVID numbers are spiking. Okay, it's dropping. Again, it's spiking. So these types of data are very much used for time series analysis. Okay, so each data has a specific requirement. Then you have this chart over here, which is called a pie chart. Again, this is very much needed while you're doing some kind of surveys or something, or when you try to get an analysis out of somewhere. So here you can get a definitive answer, right? For example, out of all engineering students, say 50% or 60% have expressed their desire to be enrolled in computer science. The remaining 30% want to be enrolled in electronics, and the remaining percentage of people want to be enrolled in EEE Mech. So no offense, but suppose this is the case. Okay, so this can be one use case, how you use a pie chart for that. Okay, then this here over here, you can see this is a stacked bar graph. Okay, and when do you use these stacked bar graphs? For example, you want to calculate a certain period, you want to find the total marks. So for example, total marks in math, physics, and chemistry. For example, this is a person's IIT JEE score. So just from the white bar, you can understand the math score is, say, something, the physics score is something, and the chemistry score is something. Okay, so that's when you can use a stacked bar chart. Okay, so enough of examples. Let us go to the next one. Okay, some more examples of data visualization methods. So these are some real life examples that you can go for. For example, a scatter plot of age and blood pressure can reveal potential relationships between variables in demographic and health data. So this is like highlight patterns and relationships, this point. So you can see that a scatter plot of age and blood pressure. So you can maybe find some relationship that with age, with increase in age, the blood pressure is also increased. You can identify potential relationships between variables in demographic and health data. Then you can say a simple bar chart showing average ratings by product category can help identify areas for improvement in customer satisfaction data. Okay. So this is like another bar chart where you're having average ratings by product category, and you can identify areas for improvement in customer satisfaction data. Okay, then we have a heat map. So heat map is slightly complicated as a data, but I'll as a particular data visualization method. But overall, just know that heat map is something which is giving you a pairwise correlation. Okay. So heat map color coding sales by region and product category can reveal which products are performing well in specific regions. So all of these maps, all of these charts and everything, they have a specific purpose. Okay. Then you can see line chart showing temperature trends over time can effectively convey information with a clear title and access labels. Okay. So as I was telling, time series data. So that's when you use line charts. So you can see temperature trends over time. So today, if you see your Google, if you just look at Google weather, okay, you can see that you can find a kind of a line or somewhere. You can see that, for example, today temperature at Kolkata is this. Then temperatures at Kolkata tomorrow will be this. If you see a rise, there will be a rise. Then so you can find that there is a line chart or something. Okay. So these are few examples of using data visualization methods for data analysis. Okay, so what we can do now, we can I can maybe show you some data visualization examples, okay, before going to statistics and all. Okay, so next we have, so just before moving into the different other data visualization techniques, I actually wanted you guys to look into a realistic data set. Okay, something that you would be working on if you are a data analyst or a business analyst. So if you're a data analyst or a business analyst or a data scientist, you won't be working on 20 rows of data. You would be working on 20,000 rows of data or even more. Okay, so let me give you an authentic example of a data set that I use a lot in my daily classes here. So for example, athlete. So there's this data set called athlete data set. Let me read it in my notebook. Okay, so you can see that this is the data that I'm talking about. So this has the concept of box plot. Okay, the reason why I'm introducing box plot is because you have learned what ZScore is. You've learned how to eliminate errors using ZScore. I wanted to show you how you can eliminate errors using a box plot as well. So data visualization technique, which is not just important for presentation purposes, but can also be equally useful from a data cleaning POV. Okay, so we're using box plot. So import Seaborn as SNS. So this is same as pandas and numpy. So just like you imported all these libraries into your notebook, similarly Seaborn is the library that you use for data visualization. You can visualize every kind of data using this, and this has a lot of inborn data sets as well. Okay, so for example, you want to do a box plot. So what you need to do is sns.boxplot, and suppose you can find a numerical column over here. Say age, height, weight, and all. So for example, you want to do this on weight. Take some time to learn. Okay, so you can see that there are a couple of, so this is what a box plot looks like. Let me give you a brief idea about what this is. So this over here, this particular line over here, this is the Q1 or the lower, the first quartile. This is Q3 or the third quartile. This particular line that you can see here, that's your Q1 minus 1.5 times the interquartile range, and this one is Q3 plus 1.5 times the interquartile range. So what was the definition of outliers? The definition of outliers was anything that goes above a certain threshold. So just by looking at this particular data, you can say that there are some points over here which are above the particular threshold, right? So for example, you can say that a person's weight is above 200 kgs. That is an outlier. Okay, so you can actually visualize which is that person whose weight is above 200 kgs and what should you do about it. In technical cases, we try to find out what these rows are all about, and if we find that it's an authentic row, then we maybe delete it. We say that these extra rows would just cause anomaly in the entire data set, so we can remove these rows. Or we can also check the data if we find that in this particular data frame, for example, you see that there is a person above 200 kg who actually exists, because this is an Olympic data set. So the person actually exists and the person's weight is actually above 200 kgs. You might not need to eliminate that row. Okay, so it completely depends on the use case. Okay, so now after going through box plot, I wanted to show you the different other plots. Seaborn we have already imported. Matplotlib is again another data visualization tool, and Seaborn is happening over Matplotlib. So that's a basic background of the thing. So suppose you have this data set, okay. So this is the name of the data set. Okay. So you have 244 rows and 7 columns. And this is a brief idea about what your data looks like. You can see columns like total bill, tip, sex, smoker, day, time, size. Okay. So what you can do is we can actually find out and see how each visualization looks like and what does this data convey as a whole. Okay. So first of all, what we can do is we can make a scatter plot. If you remember what is scatter plot used for, scatter plot is used for trying to identify the relationship between two variables. Now, how can you identify the relationship between two variables? You can only identify it if there are two numerical variables. So you technically cannot find a correlation between day and time, because sun, dinner and all. So you cannot have any mathematical approach to that. So you need to choose, say, total bill and tip, total bill and size. Does that have any relation with respect to each other? Okay. So for example, let us do sns.scatterplot. what you need to do is you just need to set the data and the x-axis and y-axis, that's all. So data is equal to tips. For example, I want to set the x-axis as total bill. Since this is a tips data set, we would always keep the y-axis as tips. Suppose this is your plot. So if you run this, probably made some spelling mistake or something. Sorry, I'm sorry. So you have x is equal to this and y is equal to tip. Sorry. Okay, so you can see that this is the relation between total bill and tip. So this is almost like a straight line, although not exactly a straight line, but you can see some level of correlation between total bill and tip. So you can see that as and when the total bill is increasing, the tip is also increasing. So just think of it as a normal scenario. Suppose you just go to a restaurant to have dosa, for example, and the dosa costs you 60 rupees. You won't give a 60 rupees tip for a 60 rupees dosa, right? Same way, for example, you have a 600 rupees bill. So it's more likely that you will pay more tip for a 600 rupees bill rather than a 60 rupees bill. So that is the correlation between total bill and tip. Okay. For example, let me tweak this parameter from total bill to size. So size basically means the size of the table which is booked or size of the family which is coming here. So you can see that this is a correlation. So you can see that normally there is no overlap, but still with more size, the tip is obviously more. So normal case, a person who is solo won't be giving more tip than a person who is a 6 family member tip, right? So that is something I wanted to show. Then just give me a minute. I'm just checking. Okay. So total bill, right? Okay, that being done, let us choose some other plot. Okay. So now we know scatter plot helps us identify relationships between two numerical variables, okay, in a data. So that we know. The next step is what were we doing? We were doing bar chart. Okay, let us do a bar chart. So this is a bar plot. So technically, this is not exactly like scatter plot, and this has a different purpose. Okay. So the purpose of a bar plot is not to find the correlation, but rather to find you an overall aggregation given by a certain level of categorical data handling. So you can see that the x-axis that I have named here is day, which is a categorical data type over here. Okay. And then I have plotted the total bill versus it. So just by looking at the data, what can you talk about it? You can say that on Sundays, there are maximum bills. Okay. People have the maximum bill on a Sunday as compared to the other days of a weekend. So here we just have four data points. One is Thursday, Friday, Saturday, and Sunday. So, but just by looking at this, you can say both Saturday and Sunday are more than that for Thursday and Friday, but still Sunday is higher. Okay. So then if you change day with time, you can say that the total bill spent during dinner is more than the total bill spent during lunch. Okay. That's again a typical observation as well. So this is something that you can understand. This is something you can constitute from here. You can also go for some other bill as well. So for example, time, you set this as. Now, it's not just lunch and dinner. Even in between lunch and dinner, you can have different types of classifications as well. So here in lunch and dinner, you can see that dinner for, so what can you talk about when you see this graph? You can say that for lunch, people were available only in Thursday and Fridays. Saturday and Sundays, people are not interested in lunch. You can say for this particular restaurant. And for dinner, people were there in all the days. However, Sunday was the day where the maximum bill was spent. So you can see a tendency of spending more money as you go towards the weekends. So that is something everyone does. Okay. Then, so this is what I wanted to show you, that it's not just one variable against the other that you can do using a bar plot. You can actually use other variables as well. You can create more legends and you can find your data. You can bring your data into more attractive formats. And this is what bar plot is for. Bar plot is to get the aggregate data. So each plot here has a different purpose. Okay, post bar chart, we have heat map. Okay, so as I was talking about, heat map is basically a correlation kind of a plot. So let me show you what exactly I mean by that. Okay, so even before going to the heat map, I wanted to show you the output of this. So for example, you've created a correlation matrix. So here you can see that the correlation between total bill and tip here you can see is 0.67. Okay, so which means it's a very high correlation. So your correlation can technically move from -1 to +1, and 0.67 means there is a very high level of correlation between the two numerical variables. And then you can even see that same level of correlation, almost the same level of correlation between total bill and size. So that's how you are getting this plot. So whatever plot you can see here, that's because of the 0.67 of correlation. Okay. Suppose that let us move into heat map, which also works only with numerical variables. So sns.heatmap. sns.heatmap correlation matrix, comma, annotation is equal to true. So now if I do a plt dot show, sorry, this is what you get. Okay, so the exact same information you get, but you can see this is a very different kind of an information. Wait, so by day and all, this is happening because all the plots have been overlapping on each other. So let us do one thing. Let us just show you the heat map. Okay, so this is the heat map. As I was talking about, correlation indices always range from -1 to +1. Okay, so -1 being exactly negatively correlated. For example, what can we say? Maybe if you are a software engineer where you are joining a company, the correlation of you becoming, or the probability of you becoming a data engineer is way more than a person who is starting with a testing profile, for example, that way. So there are way much different examples of this. So you can see the correlation between total bill and total bill, which is always 1. So that's the correlation of something when it is plotted against itself, because all the values are exactly same. Then tip against total bill is 0.68, and we have used different color coding schemes in order to show this relationship. So that's what a heat map would be doing. You can see this legend on the right side where you can see the coding, color coding. So it has ranged from 0.49 to 1. And this is how we are getting it. Okay. So heat map again has this characteristic in order to show you the relationship between two numerical variables. Okay. The last kind of plot that we are doing for this particular slide is a line chart. Okay. Line chart. So we can do SNS dot line plot. Data is equal to let us set the same data here as this one. This is the plot that you get. So this does not normally work with your numerical data type. So here, in case you had a date or something, then this would have worked well. So line plot would not work in this particular example. Might be we have to take some other example for this. But this is how the different distributions look like. Okay. So this is what I wanted to talk about in about data visualization. Okay, I hope things are maybe clearer now. Okay, so once we go to a slide, we'll be learning about descriptive statistics. Okay, so just by looking at the slide, you know that most of the terms here you already know. Maybe because you have learned this in high school math, or maybe these are just few terms that you have learned. Okay. So for example, mean, median, mode, range, variance, and standard deviation. Okay, so all of these are descriptive statistics. Mean, median, and mode fall under the measure of central tendency, and range, variance, and standard deviation fall under the measure of variability. However, we'll be doing more examples as well. So, okay. So descriptive statistics is a set of techniques used to describe and summarize data. So these are the four different types of descriptive statistics techniques that we'll be talking about. One is measures of central tendency, measures of variability. Then we are also going to talk about data distribution and correlation and regression. Okay. So mean, median, mode does not require any introduction. Mean is something which is the average of a particular distribution. Median is something which comes in the middle, and mode is something which happens the maximum number of times. Okay. Then we have some real life examples of descriptive statistics. So once after giving this example, we'll again move back into the coding part. Okay. So first of all, you have the mean salary of employees in a company can provide an overall picture of the salary distribution. Okay, so you might be going and visiting these companies. For example, if you're an experienced person, I'm sure you must be going through these Glassdoor and salaries and everything, before you are applying for an interview or something, right? So you might be going for all these figures just to see what is the average salary of a person in a particular role. So that would give you an idea of the overall salary distribution. Then the range of temperatures in a city can provide an understanding of the temperature variability across different areas. So for example, I am a person who is from Kolkata, which is very hot, okay, most of the year. And then I suddenly moved to Bangalore, which is very cold. Not cold, it has a very nice range of temperature. So that is what a range can do for you. Okay, range of temperatures in a city that can provide an understanding of the temperature variability across different areas. Then histogram of test scores can provide insight into the distribution of scores and identify any potential outliers. So outliers, again, we have discussed a lot, and we'll discuss a bit more as well later on. Then correlation between two variables such as the education level and income can provide insight into the strength of the relationship between them. So correlation is something that we were also talking about when we were doing the coding part on scatter plot and heat map, right? So you're trying to identify what is the relationship between two numerical variables. So here as well, you can see that you're trying to find out the correlation and trying to get some insight. Okay. Then the median household income can provide a measure of central tendency and the income level that divides the population into two halves. So how do you think all these classes like upper middle class, and all these come into picture? They definitely look into the median household income. Okay, right. So, these figures are very important if you want to be a data analyst someday. People would ask you a lot of guesstimates in your interview questions. So you can maybe learn about some of these data. Okay. So next you have the mode of a data set can identify the most frequently occurring value, which can be useful for understanding common preferences or characteristics. Okay. Again, mode is which happens most frequently. So next you have standard deviation. Standard deviation of test scores can quantify the variability or spread of the scores around the mean, indicating the level of dispersion. Okay, so these are some examples of descriptive statistics used in real life. Before going to any other slide, let us actually delve deeper into the different coding part. Okay. Okay. So I'll be talking about measures of central tendency. So, for example, in central tendency, you are talking about a mean of a data. Okay. Central tendency is equal to df dot mean. Then you can say okay, so central tendency is anything which is mean, median, mode, anything of that kind. Suppose you have measures of variability. Variability as in standard deviation or variance. So how much can your data vary? We have data distributions. I'll explain you what a dist plot is. This is again another seaborne kind of a data that you have. Suppose, let me, we are dealing with EF, which is this one. Let me take, say, DF of H. And lastly, we have correlation and regression. SNS dot pair plotting. Okay, so while this takes some time to run, maybe I'll just explain you quickly whatever I've done so far. So, what is measures of central tendency? Measures of central tendency is your mean, median, and mode, and that's what we have tried to find here. So we are figuring out what is the mean, median, mode in this particular distribution. Then we are finding out the measures of variability. So variability that we are doing using the standard deviation or variance. So as you know, standard deviation matters a lot when you are doing some data sets over here. So that varies a lot. And then you have data distribution. Okay. So here in this case, we'll be using a dist plot. So dist plot basically stands for a histogram plus a kernel density estimator. So maybe I can do one thing. This is taking a lot of time. We can stop this and then run this again. Just give me a minute. Okay, what we can do is maybe we can restart the kernel. This happens sometimes. Rishabh, you there? Okay, we'll continue.
Yeah, hi Tanusha, I'm here.
Yeah.
All right. Let's see, can you all
I'll
see
just
me here? Yeah, hi, Tanusha, I'm here. Okay, so we'll quickly, time for a quick break. So let me just, hope you all are able to see me. All right, I hope it's clear. So I hope you all are enjoying the session. We are going to continue the session quickly, but before that, I thought let's have a quick chat with you all. So let me know, what are you all doing currently? I want to know, you all are students or working somewhere? So a quick like information if I give you, we have been doing this workshops from quite some time. If you see our channel, we have many more live workshops like this. So you can check out our channel and you can learn a lot about new technologies. And also if you want to learn more in depth about these courses, then you can check out our website, which is edyoda.com. The link will be available in the description, where you will be able to find 150 plus such courses which are job relevant and which will help you to get jobs for whichever technology you are looking for. And yes, today as we are doing EDA, we will be continuing the session. The session is till 8 o'clock, so stay tuned. So if you want to have water or quickly take down your notes, now would be the right time to do it. And if we see on our platform, you will be able to find many such courses. So this is just an example. So if you want to learn more in detail, then the right platform would be edyoda.com. So we recently also had, so since you are trying to like learn about this EDA and Python, you might require help with resume making. That is one thing that all of you require. So there are two things when you're applying for any jobs, which is resume and second is interview. We have done a workshop on resume making. So if you want to check out that, you'll be able to find that workshop in our channel. Also, there's a complete series on interview preparation. So if you're like, you have a little bit doubt about how to give interviews, or you're scared or how should I actually give interviews, then you have come at the right place. We have a complete series which will give you a complete idea from scratch, so what to do, how to actually present yourself. Because once you do that complete course, it's a 69 part series. Yes, it might feel long, but it's A to Z everything that you require to do well in your interviews. If you watch that complete series, you will be able to attend interviews with full confidence. And if you need help with resume making, recently we had done a workshop on resume making. Link again, you'll be able to find. Just go to the channel, surf little bit on the live section in the video section, and I'm sure you'll find the content that you're looking for and you'll find it informative. All right. And with that, I hope you are enjoying the session. We'll continue this session. So before that, a quick like and subscribe to the channel. We would definitely like to see your likes and subscribe so that we can also keep making more workshops like this, more content like this. All right. So we have been doing these workshops for some time. Have you watched any of our previous workshops? Let me know. Have you watched any of our previous workshops? If not, then again, I'll suggest you that now would be the right time. Not now, matlab after you watch this session would be the right time to actually watch, go to our channel and see the workshop so that you get more idea, and you might be like whatever technology you're planning to learn, you'll be able to learn all the basics. All right. Now, before Tanusha actually comes back, I think she's not back. Okay, she's back. All right. So Tanusha, quick, my interval session I think is over. People want to see you back. They want to learn again. So I'll hand it over to you.
Sure. Yeah. So what I'm going to do, guys, is I'm going to prepare a data frame from scratch. The last time, the reason why this was taking so much time to run was because this is a data set of 271,000 rows. So I'll just make a quick data frame and show you how we are using the different measures of central tendency. Okay. So let me make a quick data frame. We hope I've imported pandas and seaborn and everything here. I'll not need to import things again. Cool. So np.random.seed42. So let me tell you what this code line is all about. So np is a numpy function. And what does np.random do? np.random would be generating you random numbers, okay, from for any given range. That's what it would be doing you. And what are we going to do? We are going to we're going to make a data out of random numbers, okay. So I'm going to make 4 columns. np.random.normal. Is anybody here familiar with the concept of a random normal distribution? People who are in EC must be knowing, or even EEE maybe. So this is something that we have been doing a lot in our classes, even before actually going into data science and all. So you must be knowing what a random normal distribution is all about. So here your data is uniformly distributed in between 3 standard deviations, and then you get the bell-shaped curve, right? So if I am to explain you that what np.random.normal is doing, so here whatever you can see inside the brackets over here, that's called a parameter, okay? So LOC is a parameter, scale is a parameter, size is a parameter. So what exactly is it doing? So LOC is the mean, okay? So basically you are creating a random normal distribution matrix in which the mean is 10, scale stands for the standard deviation is 2, and you are generating 100 such numbers, okay? Then you have np.random.normal, LOC is equal to 20. So I'm just going to paste this line of code. I'll just be changing few things over here. Then scale is equal to 5 and size is equal to 100. So do you know why I'm setting the size is equal to 100? So it's because I'm creating a data frame. That's why the size has to be the same in each and every line, right? So I'll just copy this and I'll change this into variable 3 and 4. I'll change this into 30 and this into 40, and scale would be 10 and 15. Okay. And df is equal to ed.data frame of data. Oh, I had not defined numpy because I had restarted the kernel. Import numpy as np, import pandas as pt. It should work now. Okay, so ignore my spelling mistake of variable. So, so you can find 4 columns and 100 rows. Okay. So while this is a statistics concept as well, so while we are doing descriptive statistics, this is again another statistics concept, which is a random normal distribution. And how are these numbers generated at all? So these would be, if you plot a distribution, so you will find all the column IDs of all the numbers which are there in variable 1, for example, they will give you rise to that bell-shaped curve. So its mean is 10, standard deviation is 2, and size is 100. Similarly, for the others, we have different other values. Now, if I am to run this on this particular data set, now it won't take a lot of time because now this is just 100 rows data. So if I want to find out the mean, so this is what I'll be getting if I do a df.mean. So pandas always gives you all these inbuilt functions, so you don't need to do what you did in math, right? This plus this divided by total number. So if you just do a df.mean, you'll be getting the measures. So you can find out from this that for variable 1 column, the mean is 9.79. So you can even match with whatever here is. So I had set something for LOC of 10. The variable 1 central tendency measure is 9.79. Then you have 20.11, 30.64, 41.60. Okay, so these are the different mean for each of the columns. Okay. Next, we have measures of variability, which is basically standard deviation or variance. Now, if I am to print this, let me just. So you can see that the standard deviation for each of this is 1.8, 4.76, 10.84, 13 point something. So again, this you can find from scale. So this is one method how you can actually also verify if you're inputting the correct details in the correct way, or if your functions are working normally. So here I had done df.standard deviation. So this would give me the measures of variability. Now let me show you what SNS.distplot would do, right? So SNS is a seaborn function, as you know, and it would give me a lot of distributions. So I'll just import seaborn here so that I don't get an error. And I will also import matplotlib. Okay. So now if I run this, I'll be getting a distribution. It's taking some time to load. So what is a dist plot? Dist plot is age, right? I'll have to set this as variable 1. Variable 1. Okay. So this is the plot that is getting generated. So this is what a dist plot is all about. Dist plot basically means a histogram plus a kernel density estimate. So what is that exactly? So histogram would be plotting each of your data, and kernel density estimate would be a closest fit line. Okay, and what is the density all about? It would give you the distribution of each particular variable. So what do we mean by when we see this peak at about 9, between 9 to 10? We can say that the majority of the numbers which are there in the column are in the 9 to 10 range, say 9 point something, 9.5, etc., etc. Okay, so that's what the density distribution would talk about. So if we just look at this, we can understand that, okay, variable 1 column has most of the values in the 9-point range. Okay. Then we have correlation and regression. Okay. So this is again another plot that I wanted to show you, which is called a pair plot. Again, it's nothing. It's just a good representation of the correlation matrix that you had just learned. So suppose I want to do a correlation between the different variables. This is what I'll be getting. Just give it some time to run. Okay. So you can see there are 4 variables. So this is a 4x4 matrix. Okay. So what happens in a pair plot is, in all of the diagonal plots, you will see that you're plotting it against itself. So variable 4 against variable 4 is a correlation of 1. Variable 3 against variable 3 is again a correlation of 1, and so on. That's what you can see. Then here you can see that everything is scattered everywhere. So you can't get any kind of distribution. So if you are to think about the relation that we were getting with respect to tips data set, where you could identify that when the total bill was increasing, the tips was also increasing. So that kind of correlation you cannot see right from here, right? To verify that, you can also do a df dot correlation to find that out. you can find that this is the correlation. So there is no correlation at all. So in one place there is negative correlation and others there are very small correlations. So this is a random normal distribution. So no distribution would be exactly related to another. So that's what we get from this data. Okay. So post that, what we are going to do is we are going to move to the next slide. Okay, that would be the last slide. This is called outlier detection. Okay, so again, this is something that we talked about briefly in the earlier slides as well, but now it's time to talk about it a little more. So outliers are basically data points that deviate significantly from the rest of the data set and can have a significant impact on analysis results. So first thing is statistical methods. Methods that use statistical techniques to identify outliers, example Z-score, quartile range, Mahal and Obes distance. So using the Z-score method, any data point that falls more than 3 standard deviations away from the mean can be considered an outlier. Then with visualization techniques, we can use a box plot, a scatter plot, or a histogram. So I've given you that example using a box plot. So a box plot can be used to identify outliers by displaying data points that fall outside the upper or lower whiskers. And lastly, you have a machine learning techniques. Okay, so this is applicable only when your data is ready for machine learning, not otherwise. Okay, so techniques that use machine learning algorithms to identify outliers, for example, clustering, anomaly detection. So you might be hearing these names at least somewhere, that things like k-means clustering or hierarchical clustering or anomaly detection, where you can see that there is some data point which is almost always away from the other data points. It cannot fall on the same clusters. That's when clustering comes into help, into reason. So anomaly detection algorithms can be used to identify outliers in network traffic data. Okay, that's just an example. Let me give you a practical example. Okay, so say you guys are all in college, right? I hope you guys are either in college or recent graduates. So I don't know if your college did this, but my college always said that, okay, we have an average package of 20 lakhs. Okay, so this is, you come to our university, this is the average package. But then if you really, this happened the year when I went to my college, and I was like, okay, this is a great college then. What's the harm? But then I saw the report, the placement report I saw that most of the people have received placements between 5 lakhs and 10 lakhs. And there's one guy who has received a 40 lakhs placement. And that has driven the entire mean into 20 lakhs. Okay. So that is one reason why an outlier detection is required. So what you need to do, you eliminate that 40 lakhs guy. So that's required. Okay. So that's the reason why we need to use outlier detection. Okay. So what I'm going to do is, since we already did few examples on visualization techniques, what I'm going to do is I'm going to explain you what is the math behind Z-score and why are we doing it. Okay, so Z-score, right? So what exactly is a Z-score? So Z-score is a statistical measure that indicates how many standard deviations an individual data point is from the mean of a distribution. So it is used to standardize data and make meaningful comparisons between different data sets. The formula for calculating the Z-score is Z is equal to X minus mu divided by sigma, where Z is the Z-score, X is the individual data point, mu is the mean of the distribution, and sigma is the standard deviation. So does this formula seem familiar to you guys? When if you just look at the above cells, you'll see that when we were doing Z-score, you can see that's exactly what I had done. So df of column would give me the individual IDs, right? The individual numbers, minus df of column dot mean would give me the mean of the entire column, right? And then divided by the standard deviation of the column. Okay. Then what am I doing? I'm identifying this is the Z-score. And I've set a Z-score threshold of 3. And most of the times the Z-score threshold is always 3. And if you have anything above or less than 3, you mean that is an outlier. Okay. So what are we doing in this line? We are trying to identify, we are picking only those numbers which are less than equal to the Z-score thresholds. And once we find those things, we eliminate them. Just like that 40 last time. Okay. So what are we going to do here? Okay. So Z-score you have. let me give you an example, right? Let me give you an example. For example, let us take this example for the athletics data set. Okay. Let us not do this on any other normal data set now. Let me set df is equal to pd dot read csv athlete data dot csv. This was the name? No. This one, athlete events. Okay. Now what we are going to do, we are going to calculate the z-score. So what all things do we need for z-score? We need mean, right? So mean is equal to df of, so if you want to calculate the mean of something, you need that to be a numerical column, right? So if you remember, the column name was height, weight, age. These were the only three numerical data types. So let us do this exercise for height. Okay. So df of height dot mean. Then you have standard deviation. So df of height dot standard deviation. Okay. Then you want to figure out what is df of z-score. So df of z-score would be df of height divided by mean. Minus mean divided by standard deviation. Okay, now you set the threshold as 3. As I was talking about, that if you're, you can either have things between +3 and -3. With this calculation, a lot of values will also be in the negative side and a lot of values will also be in the positive side. So if you find anything which is above 3, absolute 3, you can say that is an outlier. Okay, so suppose these are the outliers. Outliers is equal to df of absolute of df of z-score greater than equal to threshold. So what am I doing with the help of this code? I'm trying to store all the outlier data in this place. So now if I run this, I'll be seeing I'm getting 943 rows out of the 2 lakh something rows that we had. 943 rows are having a height where it is above the +3 -3 threshold. So what can you see? You can see here the z-score. If you look carefully at the last column, you can see the z-score is 3.01, 3.29, -3 point something, 4 point something. So you can see the deviation nicely, right? So the person with 3.01 z-score, they have a height of 207. The person with a 4.05 has a height of 280. Probably this is above the normal range. So that is how you get this. So again, you can see that -3.35, which means the height is 140, lower than the normal range. Okay, so these are outliers. All of these lie above Q3 or below Q1. So that's why they're outliers. So this is what I wanted to talk about. So that was at the end of the code so far. I'll just move on to the slide again, just to summarize whatever we have learned in these 2 hours. So that there's a lot, I agree, but you can learn a lot from this. So there is one step that I have not included here because that is almost like the last step of EDA and the first step of machine learning. So just including that without having machine learning would not be that great. So there would be a lot of videos coming up in the future. There might be one on machine learning, so you can maybe watch that when it comes. So this is a conclusion of whatever we had done so far. Okay. So to conclude, exploratory data analysis is a critical component of data science or analytics that involves the initial exploration of a data set to identify patterns, relationships, and outliers. Okay. First of all, data collection. That's the first step. That is, collecting data from various sources such as surveys, experiments, and observational studies is a crucial first step in EDA. Then you have data cleaning. Cleaning and preparing the data for analysis by identifying and correcting errors, missing values, and outliers, which is essential to ensure accurate and reliable results. Then you have data visualization, which are visual representations to explore and communicate insights from complex data. Then lastly, you have descriptive statistics, which are summarizing and describing the key features of a data set using measures of central tendency and dispersion to gain insights into the data. So you learned about mean, median, mode, range, correlation, regression, and all these terms here. Then you have outlier detection, identifying data points that are significantly different from the majority of the data to detect potential issues with the data. Okay, so this is what we talked about in the last 2 hours or so. So now now we are open for Q&A. Just let me know if you have any questions. I'll be happy to take them up if I can answer them, definitely. So yeah. Rishabh, you there?
Yes, I am back. All right. So time for you all to let me write down your questions in the chat box so that we can answer it for you. Tanvish, I would like to know, there was one question on our social media platform, which was, how do you know so much?
I mean, that comes with some experience and a lot of research. Recently, with ChatGPT coming up, you can research more and more just by you think about something, you write it on ChatGPT and you figure out lots and lots of things. So I think that research and doing a lot of courses and the on-place job and even teaching people and getting questions from them. Yeah.
If we can stop the screen share, people want to see.
Sure. Sorry, forgot.
Okay. Yeah, you can continue.
Yeah, so and you'll be surprised when I take a lot of EdYoda's live classes. A lot of times in the initial days, people used to ask me questions and I was like, oh, what is the answer to that? But I always made it a point that in the next class I'll be coming up with a solution and researching more on that. So that research helped me, and there's still a lot to learn. It's just yeah.
Great. So if someone wants to actually get into the tech industry, how would you suggest for them to go ahead? How should they begin their journey?
So as a fresher, right out of college?
As a fresher.
So one thing I'll definitely suggest, which is not a technical skill, is networking. Being able to network well is very, very important. So just, talk to your seniors, talk to your professors. There would be a lot of people who would be ready to guide you. And the first step is always to get an internship. So it's very difficult to get a full-time job as a fresher just out of college, because nobody expects you to learn to know all that Python and SQL. Now with platforms like EdYoda, we can do that very easily. But but normally when I was in my last year, I was having a hard time too. There were several companies which came on campus, but there's still the first step is always to do an internship and get some insights from the job over there. Then you can start from there.
Okay. And how would you suggest someone, this is a EDA course, we try to do it in 2 hours, but how much time do they need actually to study in detail properly?
I mean, we have courses for that in EdYoda, and it's this long, and this is not even step one. This is, I'll say, we can make more videos on this. We can actually do more research on this, but this is like a summary of everything, and at least 5-6 more classes you need in order to get the gist of it. Just EDA alone. Yeah.
And how would you say, currently, how is the scope in the industry if someone is looking to get into this tech field?
I'll say that a lot of people have talked about this before, that data analytics is the hottest job in the market, and it's true. Even if you want to get into data science, it's even better. And so the point is, you always have to start off as a data analyst, but after that you can go off to any field that you like, either be a data analyst or a data engineer or a product analyst or anything, right? So a person with a data analyst is always looked up to, because he or she has the technical expertise as well as the business domain knowledge as well. Yeah.
And there was one more question regarding coding, which was someone who doesn't have any knowledge from non-tech. How if someone is coding difficult or is it easy to do? What would you suggest them?
I'll just say that start with Python. It's the easiest. It's nearest to English language. So if people were looking at the screen when I was typing, I was not doing any math or anything. I was just doing df.mean. I was just doing standard deviation. It's just English and all. So I'll say that just start off with Python. In my case, I had started off with Java when I was in school. That's why I had some knowledge already, but if you want to go into data analytics, start with Python. It's the easiest. You have all these courses and everything is free right now. So yeah.
All right, great. So those are all the questions that we had. Any final thought from your side to all our viewers?
I'll say just keep looking, watching all the videos. If you want to be a good data analyst or a good data scientist, this is step one, and you'll surely go there. Just do a lot of live projects as well as learn on the go. So that would be the suggestion.
All right. And once again, thank you so much, Tanusha, that you came here and shared your knowledge with all of us.
Sure. Thank you. Pleasure is all mine.
It was a great session, and we hope that we see you again and again on workshops.
Sure.
All right. So let us know again, final question before we end this live. Which topic do you want us to make next workshops on? Let us know in the comment section, and we'll definitely try to bring more workshops on those topics. And with that, once again, a quick reminder, if you haven't still clicked on the like button, now would be the final time to do it. Like and subscribe to the channel, press the bell icon. And for more courses like this, do visit our website, which is www.edyoda.com. Link will be available in description. All right then, that will be it from our side. Thank you all for watching. Bye-bye and take care.